we're on to question 3. Okay. Here, question's asking us to evaluate the following limits. Now, note that we don't need to show any work here. Okay. So in question 2, we had to show all of our work for those algebraic techniques. Here, we do not need to show any work, right? So, looking at A, they're asking us to take the limit as x goes to infinity of this rational expression, right? What I notice with rational functions is that when we take limits towards infinity, I only need to compare the highest terms, right, or what I would call the dominant terms in the numerator and denominator. So conceptually here, I don't care about x squared and I don't care about the minus 2 because this is going to be the largest or the dominant term out of all of them. Okay? Same thing applies in the denominator. So what's the dominant term? Well, remember, it's not x squared, right? We don't want to get caught here. This is a much bigger term than any of the others, right? The minus 2x cubed because of its power, right? It's a cubed compared to all the rest. So I don't care about x squared, I don't care about x, and I don't care about 1, right? Again, conceptually. So these are the only two terms that I'm worried about. I'm worried about these dominant terms, and I'm worried about how these correspond to each other, right? What the ratio is from one to the other and how they grow. Well, in terms of growth rates, we notice that x cubed and x cubed have the same growth rate, right? They're both polynomials degree 3. And so what that means is the ratio of their leading coefficients is going to be what matters, right? So if we really thought about this, this would more or less turn into the limit as we go to infinity of 3x cubed over negative 2x cubed, right? If we ignored all the other terms. And x cubed and x cubed would subsequently cancel each other out. If we have a fraction with common terms, they can simplify. And so you're really just finding the limit of negative 3 halves at that point. And so that is just going to be negative 3 halves. Okay. Remember, we don't need to show any work here, right? So I'm just kind of discussing conceptually what was going on here. So none of this would really be necessary, right? We would just go right ahead and get our final answer of negative 3 halves, right? These should be things that we already knew, right? How to find the limit of these kind of rational functions, okay? The same thing is going to happen over here for B. So notice that B, we have a trig function, but inside of that trig function is a rational function, or some rational expression. So the limit is going to apply the same way, correct? As we take this limit, we're going to take the limit of this, assuming, of course, cosine is going to be a continuous function. So we are able to apply the limit kind of on the inside here. And what does that give me for the inside? Well, when you take the limit to negative infinity, recall that I only care about the dominant terms, the largest growing ones. So I would only be looking at x5 and x6. x6 is certainly bigger than x5, which means my denominator is faster growing, or it is extremely large compared to the numerator, which means that this would go to 0 as I go to either plus or minus infinity, right? So the bottom is bigger, we go to 0. That's a known rule. So this whole outcome then would go to cosine of 0, right? And cosine of 0, whether this is, of course, even plus or right from the left or right side, it won't really matter because cosine of 0 is 1, right? It's not going to matter whether I'm coming from the left side. One is 1, right? If I'm coming from the left, I go to 1. If I'm coming from the right, I go to 1. So my final answer there would be 1. Okay. So same logic's happening here. Let's take a look at C. A little bit trickier, but again, same concept is going to apply. We've got this cube root. Well, that can be analogous to the cosine, right? Where we have some function on the outside and we're just hoping that the inside behaves same as what we've been talking about with our rules. So what I notice here is that on the inside, as I go to negative infinity, the 3 right, subtracted wouldn't matter. This 5 over here that was being added wouldn't matter. I would only care about these x terms. And what I notice is that the ratio of these two, x over negative x, the ratio inside would be a negative 1, right? No matter what x was, yeah? because these are going to simplify and I'm going to get a negative 1. Whether this is negative infinity or positive infinity, the two are going to be equivalent. Their signs on x and x would cancel, and you'd still be left with this negative no matter what. So, with that being said, this is just equivalent to taking the cube root of negative 1. And therefore, the cube root of negative 1 is negative 1, right? Because negative 1 cubed ends up giving you negative 1. That's kind of the logic. So, hopefully all this makes sense, right? We talked about how when we're given these rational functions, if we're taking limits involving infinity, we look at the dominant terms, right? The fastest growing terms in both the numerator and denominator, and we make a claim as to whether these things are going towards infinity, going towards 0, or going towards the ratio of the leading coefficients, depending on how the degree of the the degree of the numerator and how the degree of the denominator compare. Okay, if we need a little bit of review on that, definitely let me know. We can talk about that, but those are rules. Okay, there we go for question 3.